All right, kids, today we are going to be talking about isosceles triangles and the theorems that revolve around isosceles triangles. So your notes should be out in front of you. Some of you will have yellow, some of you will have white. It's not that one's better than the other. It's just we ran out of yellow paper in the copy room. Um, Make sure that you're taking down these notes and that you're following along, and then revert to these notes when you're doing your homework tonight. Your notes, you're going to see that there's some proofs on there. Do not do the proofs. We're not going to do the proofs until I get back on Monday. They're easy, but we're going to wait. So on your homework tonight, you're only doing 1 through 8. That's just on the first side. So here we go. Let's do a couple problems. Let's see what isosceles triangles have to offer. All right, so on your notes, you should see something like this, and let's fill in the missing stuff that's in red. So isosceles triangles, as we talked about yesterday, have two congruent sides, but the definition really is they have at least two congruent sides, and we call those sides legs. So we had learned in the past that we show congruency with those tick marks. So we mark our congruent sides with those tick marks, and those are called your legs. And the non-congruent side is what we call a base. All right, so this diagram right here, this is important that you know this, because the legs, if the book were to refer to legs, you know that legs have to be the congruent side, so you give them the tick marks, and then the base, that's the non-congruent side. So that's always just, you give it no tick mark, or you can give it 2, just not the same as the ones that are congruent. Now those 2 angles that are down next to the base, these are called base angles. This is going to be something important. These base angles, all right, have some special property because of these angles, or because of these sides that are up here. Because of these legs that are congruent, the sides opposite, or the angles opposite, these base angles, they are congruent as well. So in isosceles triangles, not only do you get 2 congruent sides, but you get 2 congruent angles. Sorry, that should be an angle. I don't know why my screen, that should be an angle. Angle. Sorry. Anyway, so we're going to be using this theorem today to help us out. So down here, you can see the isosceles triangle theorem, and that's basically what I said. If the 2 sides are congruent, then the 2 base angles are congruent. So clearly, 2 sides congruent, 2 tick marks. That means that these 2 angles down here, these 2 angles down here are congruent. All right, so they have the same arc mark. So that's an important thing, that these 2 are congruent. All right, because now we can have sides congruent, angles congruent, all because we know that we have isosceles triangles. Now, the converse, which means the reverse, right? Converse means reverse, R-E-V-E-R-S-E. All right, it's the reverse of it. It means if we go in reverse, if we know that these 2 angles are congruent, all right, we now know we have an isosceles triangle, because the sides opposite them are going to be congruent as well. So these 2 are congruent, these 2 are congruent. So we have an isosceles triangle with 2 sets of congruent sides. So, all right, the last theorem, and it kind of is based off of the isosceles triangle theorem, is the definition of an isosceles triangle says that there's at least 2 congruent sides. So what if all 3 sides are congruent? Well, if all 3 sides are congruent, we call this an equilateral triangle. And we talked about that yesterday. Equilateral, meaning equal, lateral meaning sides. So equilateral means equal sides. All sides are equal. So if all 3 sides are congruent, then all 3 angles are congruent. So we're basically using the isosceles triangle theorem, stating that, hey, 1, 2, 3 sides congruent, and that should be in orange also. All right, if all 3 sides are congruent, then that means all 3 angles that are opposite these sides, 1, 2, and 3, those are all congruent as well. So isosceles triangles, equilateral triangles, any sides that are congruent in the same one triangle, the opposite angles are congruent. So we're going to be working on this for the next couple days. So it's going to be important that we are working with this and seeing what's going on. So let's flip the page. Let's go to a couple examples. Now, there's one more theorem that's the converse of the equilateral triangle. Converse meaning reverse, saying that if all 3 angles are congruent, well, then we know that all 3 sides, 1, 2, 3, and that should be in a different color. 1, 2, 3, those all should be congruent as well. All right, so angles and sides, they actually do have a relationship together, but it must be in the same triangle. Sides and angles must be in the same triangle. All right, so a lot of you are going to start seeing problems when there's multiple triangles and say, oh, I see these tick marks here. That does not mean that opposite angles are congruent. It has to be same sides in the same triangle are congruent in order for opposite angles to be congruent as well. All right, so let's go through a couple problems and then get you started on your homework. So number 1, If you look here, we want to identify a couple things. Number one, there's tick marks. Look at these tick marks. Those tick marks mean those sides are congruent, which we learned now that opposite angles, all right, this angle and this angle must be congruent. So what should be the measure of x? X should be 44 degrees. Now, number two, again, look at what's given to you. We have a side congruent, we have a side congruent in the same triangle. Now, here's the deal. Yes, these sides congruent means that these angles are congruent. But I don't have an angle measure here. I don't know what that is, and I don't know what that is. Uh-oh. Well, here's the thing. We do know that this vertex angle, 96, we know what that angle is. So what we can do is we can take the sum of the triangle's angles is 180. We'll subtract 96 out of it. So we're going to get 84 degrees. Now that 84 degrees is equally shared between these two angles. So since it's equally shared, we will divide this by 2, and we're going to get each angle to equal 42 degrees. So each angle is 42 degrees. 42 degrees. And I don't know why like another color comes in there. So if you're looking, that's not an 8, that's a 2. That's my computer just being awful. So you can tell the school and complain to the school that your teacher's computer is awful and it's impairing your learning. Anyway, here we go. Let's go down to number 3 now. So this is similar to some problems we worked on yesterday. So now we have multiple triangles in here. So you really have to focus on one triangle at a time. Triangle 3, we're going to start with this triangle right here. All right. Now in this triangle, again, we start off, we know these two sides are congruent, which means that these two angles opposite it are congruent as well. So we do what we did in the last problem. We go 180 minus this angle, minus 96, and you're going to get 84 degrees. Now that's split equally between these two angles, so it's 42 and 42. All right, 42. I don't know why that blue thing keeps showing up. So now, all right, now that we have another angle here, what we can do is we now can work on this triangle. Let me get a different color. What do we got here? All right, now we're going to work on this triangle here. All right, now I'm going to kind of make this triangle a little bit bigger so we can work on it. All right, so in this triangle, where's my pens? Let's go, pens. Come on. Here we go. We got C, tick, tick, D, tick, tick, E. All right. So now in this triangle, since we know this top angle up here is 42, by vertical angles, this top angle C or ECD has to be 42. So what we'll do is we'll use the same exact property that we used over here. If we know this angle up here is 42, because of isosceles triangles, we can say that these two angles are congruent. All right. So we can go 180 minus 42 is going to give you 138, and we'll divide that by 2 because each of these equally have to share that 138. So it's going to end up being 64, or sorry, no, that's wrong. 60. What is it? Somebody stole my calculator. Oh, 69 degrees. 9 degrees. 69 degrees. So that's how you're going to be working with isosceles triangles, all right? You have to work from one triangle to the next to find all your missing angles here, all right? Let's go to number 4 now. So here we go, number 4. So again, we have two triangles. We have this triangle in lime green, and we have this triangle that's in yellow. Now, before we get started on this, if you're barely writing this stuff down right now, remember, you're watching the video, just pause it. Pause it, go back, look at this. Me, I'm just going to keep talking because you can pause. It's not like class, all right? You can pause it, go back, look through this, all right? Remember, you got 2 teachers there who are awesome. They can definitely help you out with this, and I'll be back on Monday, but you should be able to pick this stuff up pretty quickly. You guys are all bright. So let's go back to problem number 4 now, okay? So problem number 4, we cannot start with the lime green triangle because there literally is nothing in there besides 2 tick marks. So what we're going to have to do is we're going to have to work with the yellow triangle first. They give us this angle of 26. Now this angle of 26 is one of our congruent angles because we have our sides that are congruent, which means our angles down here, this and this, are congruent. Let's put that in a different color. This and this are congruent. So what we do is we're going to make this 26 degrees here, all right? And we can do one of 2 things, all right? The problems up here say find all your angles. So we can find angle A up here at the top by going 180 minus 26 minus 26. Just take away these two angles and you are going to get 128. All right, so this angle is 128. Awesome. All right, now to find an angle in here, what we're going to do is we're going to use linear pairs. We're going to use linear pairs here. We're using this 26, so we're going to go 180 minus 26, and you're going to get 154. So this angle right here is 154 degrees. Why is it doing that? Whatever. All right, it's 154. All right, that's what that angle is. Anyway, so now this green triangle, it's hard to see, but it already has a tick mark here that's used in this yellow triangle, but it has the same tick mark here. So the green triangle is actually an isosceles triangle as well, showing that this angle and this angle are congruent. So they are going to share equally whatever's left in this triangle. So we're going to go 180 minus 154 is 26. And that is the remaining amount of angles that we have left. So we're going to divide 26 by 2, and each angle is 13. All right. So that's how you would do that. Again, you're just using the sum of triangles, angles, which is 180 degrees. We're using linear pairs. We're using the isosceles triangle theorem and its converse, all to give us all this stuff. It's really impressive what we can do now with our knowledge of isosceles triangles. All right, let's see what else we have. Okay, cool. So we'll just do a couple more and then you can get started, because literally these are all virtually the exact same thing. So now, up here in problem number 5, all right, problem number 5 says solve for y, then find all the angle measures. All right, so again, just like what we were doing before, we're going to use isosceles triangles, but what we're going to do is we're actually going to have to solve equations first in order to get the value of y, to substitute it in to find the value of our angles. So let's look at what we have here. Well, again, I identify it's an isosceles triangle because of these tick marks. And because of these tick marks, I know opposite angles, angle B and angle A, are congruent. Now, if you look here, we don't have a value for A, but we actually do, because if B and A are congruent, I'm going to call A 6y plus 1. So now, to help us first find the value of y, what we're going to do is we're going to add up all of our angles, all of our expressions. So we're going to go 21y plus 13, that's the value of angle C, plus 6y plus 1, that's the value of A, plus 6y plus 1, that's the value of B, and that equals 180 degrees, because all three angles of a triangle add up to 180 degrees. Now, that's your geometry. This second part, solving this equation, this is algebra. This is stuff that you should have been able to do prior to coming to this class. So we got to just remember our rules. Combine like terms. So let's combine all of our variables together. 21y, 6y, and 6y is going to give us, what is that, 33y. Yeah. And then we're going to combine our constants, 13, 1, and 1. So 13, 1, and 1 is 15 equals 180. So now that we've combined all our like terms, now we try to get everything away from our y's. So we're going to subtract 15. Oh, geez. Looks good. All right. Sorry. Bear with me. I'm writing on my computer. It's awful. So 15. We're subtracting 15, so we get 33y equals 165. All right. And then we divide by 33, and you're going to get y equals... Where are we at here? 165 divided by 33, and you're going to get 5. Now, all right, that is one of our answers. All right, we want to know what the value of y is. Now, we want to find all of our angle measures. So what we're going to do is we're going to take this 5 and we're going to substitute it back in. Let's put this first back into angle B. So 6 times 5 is 30 plus 1 is 31, which means angle A has got to be 31. Which means that when we substitute this back in, 21 times 5 is 105. 105 plus 13 is 118. Bam. And that's how you get all your angle measures. All right, let's do one last problem. We're going to do number 6, and then you're going to get to go and start your homework, okay? Number 6, it says solve for the value of x, then find all your side lengths. Now, we're finding side lengths. So we can't just go and take AC, CT, and AT. We can't take this, this, and this. These all equal 180? Question mark? No, they don't equal 180 degrees because sides can equal whatever they want. They can be as big or as little. So you're not going to set them equal to 180. What you're going to do is you're going to have to look at what we have here. And we have isosceles triangles, which means that these two sides, this and this, are equal to each other. So that's actually how we're going to start this problem off. We're not going to add them up and set them equal to 180. We're going to take our two sides, which are congruent to each other, and we're going to add them or set them equal to each other. So we're going to go 6x minus 5 equals x plus 10. So now we got variables on opposite sides. So we move our smallest variable first. So we subtract x. So we get 5x minus 5 equals 10. We'll add 5. We get 5x equals 15. And x equals 3. All right. So now we have the value of x. So now we have to find all of our side lengths. So now we're going to take this and we're going to put this in here, here, and here. So we're just going to put 3 in there. So for this first side length, AT, we're going to go 3 plus 10 is 13. 6 times 3 now. So now for CT, we're going to go 13. And you can't even see that. 13. Oh, and it does it again. 1, 3. Okay, cool. Now for CT, you're going to go 6 times 3 is 18. 18 minus 1, or 18 minus 5 is 13. Oh man, they're the same thing. Yeah, and that's because they're equal. And now 3 times 2 is 6 plus 11 is 17. So, all right, we're going to just kind of scrap the rest of these. I think you have enough to work on. All right, you have 8 more problems to do. All right, so when you're done with your notes, you need to go up to your sub and you need to ask the sub for your homework, all right? Make sure you show them your work, show them that you've done this, all right? And sit down and just work on your homework. If you want to work in your group, that's perfectly fine. Make sure that you're talking with each other. When you're finished with all that, all right, just put your head down, go to sleep, or if you have other homework, go ahead and do that. Please don't be a jerk to the sub, all right? If we're good, I'll make sure Mrs. Quatman brings you cookies in on Monday, all right? And she's looking at me right now, and she said she will. So, all right, I will see you guys all on Monday. Make sure that you're good to the sub, all right, and have a great day. All right,